chi-square goodness of fit test on a tax preparation problem. How do you prepare your income tax return? A random sample of 400 taxpayer falls into the following categories. So they are either using an accountant, using a software, using community service, or they ask a friend to do it. The expected distribution in percentage are provided below. The significance level is 10%. So the 40%, 30, 20, and 10% means like on average, like usually 40% of the people they will go to an accountant, and then 30% of the people they will just use a software, do it at home. 20% of the people they will use community service. So community service is they have in some agency they have volunteers to do this for free. Okay, and then the friend, if your friend is very good at this, then you just ask your friend to do it. So the percentage means on average 10% of people do this, 20% of the people do this, 30% of the people do this, right, on average. And then you collect a random sample of 400 taxpayers. It turns out that 150 of them use an accountant, and then 130 of them use software, so on and so forth. So the first step is, how do you calculate the expected frequency? Observed frequency is data. That means you run a test, or you do an experiment, not run a test. You do an experiment and then you collect numbers from the experiment. That means you are writing down the result. So that is observed frequency, which means the data. And then expected frequency, you don't collect this data, you have to calculate those frequencies by doing what? By taking the sample size, which is n, times each individual percentage. So for example, the first one, so this is 400 times 40%, and then this is 400 times 30%, and then 400 times 20%, and then 400 times 10%. This one, you just use your calculator to do it. So 160, this is 120, this is 80, and then this is 40. So there you go. You have your observed frequency and expected frequency. And then the next step is setting up the null hypothesis and alternative hypothesis. So let's use a different color for that. So simply speaking, for goodness of fit, the H0 is always fit, and then the HA is always not fit. What is fit? What is not fit? You are comparing two columns of numbers. The first column is observed, the second column is expected frequency. The easiest way ever is like buying a new pair of shoes. So when you go to a sneaker store, buy a pair of shoes, what do? You are trying to, you have to try on the shoes first, right? To see if that fits or not fits. So you put your foot in the shoes to see if that is a fit or not fit. So there are two possible outcomes, either fit or not fit. So that is how I picture the chi-square goodness of fit test in my mind. Try out a new pair of sneakers to see if they fit or not fit. Just means trying a new pair of shoes, either fit or not fit. So that is chi-square goodness of fit test. Okay, let's elaborate a little bit more. So the null hypothesis, the H0, so in terms of this problem, I will say the observed test preparation method frequency fit. So let's just do the writing. The observed tax preparation method frequencies fit the expected test preparation method frequency. Expected tax preparation method frequencies. All right, and then the HA, all you have to do is you copy the whole sentence, except you change the fit to not fit. All right, that is the alternative hypothesis. And then next step, you calculate the test statistics, right? So in a z-test, in a proportion, in a t-test, we do have a formula. The formula for chi-square, let's use a different color for that. That is a chi-square. So this is a chi-square symbol that equals to the summation of observed minus expected squared divided by expected, and then you do this for every single row. So let's do the first row, accountant. So that will be a 150 minus a 60 squared divided by 160, and then you plus 130 minus 120, so that will be for software divided by 120, and then you plus 83 minus 80 square divided by 80, and then plus 37 minus, you might already notice this, 40, right? Here. Copy the problem wrong, minus 40 square divided by 40. So what is that equal to? Do you need to calculate this by hand? No, you don't need to. So the next step is use your calculator. So let's take a look at the first screenshot right over there. So we go to stat edit. So on your graphing calculator, you click stat, you click the stat key. The stat key is on the left side of the left arrow, stat, and then you go to edit, just right over there. Click stat, and then the edit is right in front of you. Click edit, and then you have a few columns, right? So if you want to erase the old data, just put the cursor on top of a list. So let's say you move the cursor, hit the up arrow, tap the up arrow, move the cursor to the top of L2, hit enter, hit clear. So that is how you clear one column. And then you put observed in L1, expected in L2. So now the data is done, and then you move on to carry out the test. So you go to stat, you hit the stat key again. This time you use the right arrow to go to test, and then you go down to find chi-square GOF test, so goodness of fit. The other one, the chi-square test, that is for test of independence. That is another story. So chi-square GOF, goodness of fit, and then you click enter. That brings you to the next screenshot. So observe in L1, expected in L2, the degree of freedom, you have 4 categories. Then you use 4 minus 1, and then once you hit calculate, that brings you to the next menu. Then you will get the chi-square. So in this problem, the chi-square is approximately equals to 1.796, and then the p-value is pretty big, 0.6154. So that is greater than 10% alpha. So greater than 10% alpha, that means you fail to reject the null hypothesis. And then do you see that there is a CNTRB? So the CNTRB 0.625, 0.625, that means that is for the first fraction. 150 minus 160, that is negative 10. You square that divided by 160. The answer is equals to 0.625. So you sum up all the fractions to get 1.796. Okay. All right, so we got the p-value that is greater than alpha. Then my conclusion is we fail to reject the null hypothesis, right? So let's write this down. So since p-value is greater than alpha, we fail to reject H0, so we cannot prove HA is true. HA is true. That means we cannot prove the observed text preparation method frequency do not fit the expected text preparation method frequency. All right, so that is the end of the test. And then if you hit draw, because sometimes they ask you to sketch a graph, if you click draw, do you see this? Do you see this? So this one is the graph. So the curve is the chi-square, and then the cut is where the chi-square test statistic is. So 1.7958, and then the p-value, goodness of it, is always right-sided. So you have the p-value on the right, and then speaking of the p-value, you might be wondering, hey, the p-value is pretty big, and here is why. Look. P-value is pretty big. What does that mean? Big p-value, that means you fail to reject the null hypothesis. That means HA is true. So fail to reject H0. Let's say this again. Fail to reject H0. What is H0? H0 is fit. Observe fits frequency. Observe fits expected. You fail to reject this. So that means there is a fit. The word fit is suspicious. Take a look at the last term. The last term, do you see that the last term? Let me just draw a line. and then I want to split this up. The last term, do you see that that is a 37 minus 40 squared divided by 40? 37 is observed, 40 is expected. Do we agree that these two numbers are pretty close? So this is equals to a negative 3 squared divided by 40. So to give you a better a very clear contrast, how about this? What if I have 1 minus 40 squared divided by 40? Which one is big, which one is small? Clearly, the 1 minus 40, this gives you a negative 39 square minus 40. Negative 39 square is a huge value. Divided by 40, that is still very big. So that means the second fraction is greater than the first fraction. So this, you have small fraction. This, you have a big fraction. And then what is the formula? What is the formula asking you to do? The formula is asking you to find the summation. So this, you have a sum of small number, small, versus the sum of big numbers. Which one gives you a big chi-square? The answer is that leads you to a big chi-square, right? And then this leads you to a small chi-square. What's the difference between small chi-square and big chi-square? When the chi-square is small, which is in this case, the cut is so close to the vertical axis, and then this is a right-sided test, so that's why the p-value is big. When the chi-square is small, the p-value is big, so most likely you will reject, and then the fit remains suspicious. Of course, you have 37 versus 40, so it is reasonable to believe that 37 fits 40. All right, if you take a look at the 1 and the 40, the 1 there is no way to say they are close, so there is no way to say one fits 40. So that's why in a big chi-square, just like I have another the previous problem has a big chi-square that pushed the chi-square that pushed the cut so far to the right, and then you have a tiny p-value on the right next to it. So that's why in that case that will be a reject. Okay, so speaking of the p-value, how do you find the p-value without using the chi-square goodness of fit? So you will have to use a chi-square CDF. You go to second, and then you go to vars, you select chi-square CDF, and then once you click enter, that leads you to a menu. The lower limit, you put the chi-square in. The upper limit is a very big number. I use infinity. The way I type infinity is I type 1, and then the base 10, the little e, is second comma. That gives you the e. Do you see that there is a double e above the comma? And then you type 99, so that's how you type the base e. And then you type 99, the degree of freedom for category -1. Once you click the paste, the command will go to the home screen. Click enter to get the p-value. So if you are using an older calculator, they will give you the chi-square CDF on the home screen. They will ask you to start inputting numbers, so they won't show you a menu that walks you through. Don't worry about that. Just type those 3 numbers in that order, separate them using a comma, and you will be able to get the p-value. All right. So that is officially the end of this problem and this video. If you like it, you think this is helpful, give me a like, share, and subscribe, and I will see you all in the next one. Signing out.